All right, for writing piecewise functions, what we're going to do is we are going to look at our graph, and we need to write an equation for each graph that we can visually see. So for example A, how many equations are we going to have in this f of x function? We're going to have 3. Okay, how many are we going to have for g of x here? 2. In C, there is an actual point here that you can't see. It kind of shrunk in printing. So there's a point here at 3, 1. So how many equations are we going to have for C? 3. So we're going to have something to show this, this, and this. Okay. So let's go back to A. What we want to do is we want to first start by writing the equations of each line. So what are we going to do to write the equation? What do we need here? We first need the slope. So slope is easy to find here. So what is the slope of this line? Negative what? So negative 1/2 is the slope. Okay. Can we visually see the y-intercept here? No, it's somewhere in this vicinity. Since you can't see it, all right, then we want to pick a point. My suggestion, anytime you have an x-intercept, that's always a good point to use. So what is this point here? Negative 3, 0. And you can certainly put this point into y equals mx plus b. So put this in and this in, solve for b. I'm going to use point slope for us. So I get y minus 0 equals negative 1/2 x plus 3. So then y equals, when you distribute the negative 1/2, you get negative 1/2 x minus 3/2. All right, so we have our first equation. All right. The second equation, what is the equation of this line? Y equals 2. Perfect. And then for the last part, we first find the slope here. What's the slope? Negative 1. And we don't have the y-intercept, so I'm going to purposely choose the x-intercept for my point. And what is this point? 7, 0. So plugging into point slope, I get y minus 0 equals negative 1 times x minus 7. And then I distribute the negative 1, and you get negative x plus 7. Okay, so what's nice about this is we actually have our 3 equations. All right, generally when you're writing piecewise functions, you would write your equations from left to right, kind of following the domain from left to right. So f of x equals negative 1/2 x minus 3/2. So that's the purple guy here. All right, the second one is just 2. Notice I'm not writing y equals for all these because my y is f of x. All right, so I'm just writing the other half of the equation. And then, bless you, and then negative x, whoo, bless you,
Thank you.
negative x plus 7. All right, now you guys are more than welcome to look at the graph and then kind of figure out the x values where these exist. I do find that it is helpful for people to draw a number line. So let's draw a number line above, and this is going to represent our x values. And what you're going to do is you're going to look at your graph, and this graph goes all the way up to this x value, which is what? Negative 1. Now this graph starts here, so I don't need to write another tick mark, and this graph goes to 3, and then this one starts there, so I don't need another tick mark. So what I have here then is this is all the x values where the purple part exists. This is all the x values where the yellow exists, or the red exists. And this is where my light blue is. Okay. So here, if you look at the notes on the back, notice I had these 3 equations, and then I have where it exists for x in this inequality format. All right, this is what we are trying to do now. So it only equals x plus 4 if x is in between negative 6 and 2, where 6 was included. So coming back here, all right, if I need to write an inequality for this, when does this purple graph exist? Only if x is what? less than negative 1. Okay, so this is where this number line comes in really handy, because if you're writing inequalities, it's a lot easier to write it from a number line than it is from this. Okay, so here, notice my x is at negative 1, and it's everything less than that. That's why it's x less than negative 1. But by drawing it on the number line, just visually, I feel like it's a little bit easier to see. So then how do I write this? It's in between. So if it's in between, okay, and then what do we notice about these? The points, open or closed? Closed, so what do I need to change here? Equal to. Okay, and then how would I write this last piece then? So how would I write an inequality for the blue? If x is greater than 3, do I leave it open or closed? Open. Okay, everybody good? Okay. Now, example A is actually the hardest of the 3 examples. All right, so let's take a look at B. Why is example B easier?
There's only 2.
There's only 2, so that's a start. Why else is it easier? There's one other reason why.
Oh, and you have the y.
You have the y-intercept. Why is it so convenient to have the y-intercept?
Because you could just do y, or you could do y equals mx.
You can do y equals mx plus b right away. Oh, you're on fire. All right, so here we go. For this one, what is the slope?
1. Negative 1.
Negative 1, right? Down 1, right 1. Okay. What's the y-intercept? Negative 2. So we already have y equals negative x minus 2. So much easier to write the equation. Okay. For this one, what is the slope?
1.
Positive 1. What's the y-intercept? 2. So then we get y equals x plus 2. And then let's go ahead and draw our number line here. All right, so this is my x values. And I start at negative infinity, and I go all the way up to what for this graph? To 0 here. Okay. And this one starts at 0 and goes to the right. So if I'm shading, my pink graph is going to exist here, and my green graph is going to exist for all of these x values. So when we do g of x, I have my 2 functions, negative x minus 2 and positive x plus 2, if, all right, for this one, negative x minus 2, what am I going to write? It's this set here, less than 0, and then take a look at my start point. What do I need to change? Y, less than or equal to y though. Because this is a filled in circle. This is a closed circle here. All right, so that's going to be less than or equal to. How about x plus 2? When does that exist? When it's greater than 0. Can I leave that? Why? Because of the open circle. Okay. I want everybody to try C. Try C. How many equations are you going to have, first of all? 3. 3. Remember, if you didn't do it already, you need to have a point here. All right, it's on there already. It's just very light. So you're going to have 3 equations for h of x. Everybody try it out. All right, hopefully you guys got the 3 pieces. So we have h of x. We have this first function here. This is just negative x, all right? But when does it equal negative x? So if this is 3, so it's if x is less than 3. When does it equal 1? Yeah, x is equal to 3. It only equals 1 when x is 3 and in no other spot. So this is not an inequality because it's a point. Okay, anytime you have a point, then it's x equaling the x value, and then this is your y value. And then when does it equal y equals 3? So the blue part here. So if x is greater than 3.